Hello everyone. Today we will discuss about the distributed acoustic sensing techniques for the subsurface imaging. So in these techniques, first we will discuss about the instrumentation. So in these techniques, there is a acoustic sensors which are placed. So these are the kind of computer device, IDOS device. So from this device, there is a one optical fibers which is connected, and it is installed in the subsurface, and when there is some kind of disturbance nearby these optical fibers, so this laser pulse inside these optical fibers will be back scattered, and it is reported to this point. So it is instant process to signify where there are where there are some kind of disturbance beneath the ground surface, or the places where this is used. So there are wide range of applications of this distributed acoustic sensing techniques, which are pipeline monitoring, well bore monitoring, earthquake detection, subsurface imaging, flood monitoring, perimeter security, railroad monitoring, traffic monitoring. So first application is the pipeline monitoring. So in the pipeline monitoring, so we have this underground pipeline. On the top surface of this pipeline, these optical fibers are placed, and it is connected to this instrument, DAS control system. So suppose at this particular point there is some heavy machine. So due to this, there is a disturbance in the pipe will happen, and this can be indicated in the screen of this control device. So it will instantly detect where there is difference, and what are the significant amount of damages can be possible. Further, for subsurface imaging, there are various kind of boreholes are there. So suppose these upper surface are it is kind of ground surface. On the ground surface, these optical fibers are placed in the grid manner, and corresponding to the downhole, and corresponding and the relative in the relative borehole, these optical fibers are placed inside it. So it will measure the disturbance along this horizontal plane as well as along the depth. So by measuring, by detecting the disturbance towards this configuration, we can provide the subsurface imaging of the ground strata. Now, this distributed acoustic sensing is a continuous monitoring of acoustic signal along a optical fiber. So we can say these optical fibers are a representative of a large number of seismic sensors, and all points are a kind of measurement points in this system. So if we will talk about the working process of it, so this optical fibers uh, are used. So in the first step, there is a injection of the laser pulse inside this optical fiber. So this laser pulse, once the laser pulse injected inside the optical fiber, so the back scattered lights uh, are observed. So this backscatter lights carries the information about the environment acoustic characteristics, including the intensity, frequency, and directionality of the acoustic signal. Further, from this collected data, we will do the interpretations and analysis. So for interpretations and analysis, the advanced signal processing algorithm are used, and meaningful conclusions are made. Further, for continuous monitoring, so this capability enables applications such as subsurface imaging, water seismic monitoring, oceanography research, marine mammal detection, underwater infrastructure monitoring, etc. Further, let us understand how this distributed acoustic sensing techniques are installed. So for that, this optical installation of this optical fibers are placed in the beneath the surface of the earth. So it is generally placed at a depth of in between 1 to 2 meter, and in between 1 to 2 meter there are it is placed inside the PVC pipe, and it will take the this PVC pipes is having the diameter of 10 to 15 centimeter. So in this way it is placed, and from this from this optical fibers, the control unit will be connected, and that will give the significance nature of this particular uh, signal. So uh, for the measurement of this acoustic signal, so for that, this in this optical fibers there are number of piece of glasses are there, and these piece of glasses uh, are placed randomly inside this optical fiber. So once the laser coherent laser pulse inserted into this optical fiber, inside this optical fiber, so elastic Rayleigh scattering happens, and due to this uh, some of the pieces of glasses are uh, act as a back scattered, and due to back scattering we will get the signal on the control unit. So this signal is measured, or this signal can be represented by the function of intensity along this length of the optical fibers. So from these signals we will get the position of the strain changes along this fiber. So generally what happened in this case, we will measure the local strain rate inside the uh, optical fibers. So if there is some kind of random changes are occurring due to the any abnormal phenomena, so that is figure out using this DAS techniques. So this DAS techniques is kind of uh, as I have earlier discussed about, it is kind of some optical fibers. So these fibers work as a sensor. So in this case there are various advantages of using these techniques. So first is there is not any determined points. So all continuous points are working as a sensing points. So the sensing can be done along the entire length of the cable, and as I told about it, it will measure the continuous and real time signal. So that's why it is quite helpful for the subsurface imagining, and it is kind of new process. Further, there are two techniques. First one is the MSW techniques, and second is the this new developed uh, this DAS techniques, distributed acoustic sensing techniques. So this MSW techniques also provide the subsurface imagining by estimating the shear wave velocity profile. However, this DAS techniques gives the subsurface imagining from the optical fiber by sensing the signals in the optical fibers cable. So now we will understand what are the significant differences in terms of the observation principle and the depth of investigation. So in distributed acoustic system, distributed acoustic sensing techniques, the lights are back scattered along the optical fibers cable to detect the acoustic signal. However, in MSW, this is multi-channel analysis of surface wave. In this, propagation of wave happens, and which is measured by the geophones, either it is passive or it is active. The depth of investigation in distributed acoustic sensing depends upon the subsurface conditions along the entire length of the optical fibers, and it will depends upon the factors such as the cable installation depth and property of the surrounding material. However, in the MSW techniques, the depth generally varies from 30 to 50 meters. In some of cases, it will go up to the 100 meter, but it will depend upon the frequency range and the subsurface wave characteristics and the geological conditions. So now sometimes this MSW techniques, the depth of investigation is also depends upon the array length. So now in terms of the data acquisition and processing system, so it will, so this DAS techniques acquire the data continuously along the entire length of the optical fibers, and there are specialized equipment which are used for signal processing and the interpretations. So that means in this DAS, distributed acoustic sensing techniques, we use the advanced signal processing tools. In MSW, we use the geophone or accelerometer to record the wave field, and these wave fields are converted into the frequency domain, which is represented by the dispersion curve, and dispersion curves are inverted to estimate the VS profile. So this VS profile gives the variation of the soil strata along the depth.